All right, so suppose that we have a right triangle. So here's my right angle, 90 degrees. First thing we should notice is the hypotenuse. So the hypotenuse is always the side directly across from the right angle. So if this is my right angle, this side would be the hypotenuse. Okay, and then we have two other terms that we need to talk about. We have the opposite side and the adjacent side. And now your hypotenuse will always be the same no matter what. It's the side directly across from the right angle. Opposite and adjacent sides are relative terms. They're relative to the angle that you're talking about. So if I'm talking about this angle theta, the opposite side would be the side opposite that angle. So this would be the opposite side. If I'm talking about this angle, so relative to this angle theta, this would be the adjacent side. It's adjacent to the angle. Okay, now again, those are relative terms. Opposite and adjacent are relative. If I'm talking about this angle, so if I'm talking about this angle up here, this would be the opposite side relative to that angle. And this would be the adjacent side relative to this angle. So when you talk about these terms opposite and adjacent, you have to know what angle you're talking about. All right, so then we have some definitions. So we're going to define that the sine of theta will be the ratio of the length of the opposite side to the length of the hypotenuse. So sine of theta will be opposite over hypotenuse. Cosine of theta we're going to define to be adjacent over hypotenuse. And the tangent of theta will be opposite over adjacent. Okay, you need to memorize these definitions. You need to know these by heart. All right, so let's look at some examples now. So say I have this right triangle. This angle is 50 degrees, and this side is 10 inches long. All right, we want to solve the rest of this triangle. So we want to know everything there is to know about it. We want to know the size of this angle, the length of this side, and the length of this side. All right, so let's jump right in. Let's try to find the length of this side. Let's call it x. All right, so how can we do that? So if we think about this angle, 50 degrees, what do we know? We know the opposite side. We want to know the adjacent side. So out of those three things, we know two of those. We know the angle and we know the opposite. We want to know the adjacent. Well, which one of our definitions involve the angle, the opposite side, and the adjacent side? Well, that's tangent. So let's use that. So the tangent, and my theta in this case will be 50 degrees. So the tangent of 50 degrees is equal to opposite, which is 10 inches, over adjacent, which is my x. Okay, so now I want to solve that for x. So I'm going to multiply both sides of this equation by x. So that'll give me x times the tangent of 50 degrees is equal to 10 inches. Okay, now to get the x by itself, I need to divide both sides by the tangent of 50. So x is equal to 10 inches divided by the tangent of 50 degrees. All right, let's find an approximate value to this. So I have 10 inches divided by, and now I'm going to ask my calculator to give me an approximation for the tangent of 50 degrees. So tangent 50 is approximately 1.19. All right, so then if I do 10 divided by that number, I get approximately 8.39 inches. Okay, so this side is 8.39 inches approximately. So that's an approximate number, not exactly. This is an exact answer. This is the approximate answer. All right, let's see if we can find some other sides. So let's find this side. Notice this is the hypotenuse, so let's call it h. I know there's different ways of finding it. One important way that you guys should know already, if you have a right triangle and you know the length of two sides, you can find the length of the other side using a really famous formula, the Pythagorean theorem. So I could do this side squared plus this side squared equals this side squared. But since we're studying right triangle trig, let's practice using that. Okay, so let's find the length of side h. All right. So again, let's use these things that we were given, the 50 degrees and the 10 inches. All right, so relative to this angle 50, I know the opposite side, and I want to know the hypotenuse. Which of these involve the angle, the opposite, and the hypotenuse? Well, that would be sine. So let's use that. Let's say the sine of 50 degrees equals the opposite, which would be 10 inches, over the hypotenuse, which is what we want to know. All right, let's solve that equation for h. So I'm going to multiply both sides by h and get h sine 50 degrees is equal to 10 inches. Now divide both sides by the sine of 50 degrees, and I get h equals 10 inches over the sine of 50 degrees. Okay, so this would be the exact answer for the length of that side. But let's find an approximation to it. Okay, so I'm going to ask my calculator to do 10 divided by the sine. I can't find the sine of 50 degrees. And my calculator tells me approximately 13.05 inches. So this side is approximately 13.05 inches. All right, just for fun, let's check and see if these numbers really obey the Pythagorean theorem. So if these numbers are right, then 10 squared plus 8.39 squared should be approximately equal to 13.05 squared. Again, approximately equal to because these numbers are approximations. All right, let's see if that works. So 10 squared, that's 100. 8.39 squared, talk to my calculator. And I get 70.39. So we're asking this question here. And then 13.05 squared is 170.30. Also, is this true? 100 plus 70.39, that would be 170.39. And you can see it's really close. It's not exact because, again, we rounded these numbers off. They were approximations. But it's close enough that we can be confident that those are correct. All right. So again, exact answer here. This is just an approximation. All right, one other thing about this triangle we need to know. We found all three sides. We know the size of two of the angles. We just need to know the size of the other angle. Well, that's really easy. What do the angles of a triangle, what do they sum up to? You guys remember that from geometry? The angles of a triangle sum up to 180 degrees. So this is 90. So these other two have to sum up to 90. So if this is 40, then obviously this would have to be, sorry, I don't know what I just said. If this is 90, then these have to sum up to 90. So if this is 50, then this has to be 40 degrees. All right, so now we've completely solved that triangle. We know the length of all three sides, and we know the size of all three angles. All right, another example. Let's solve this triangle. So here, I'm giving you the length of two sides, but I didn't tell you these two angles. Okay, so our job is going to be to find the size of these two angles and the length of this side. Okay, there's multiple ways we could go about doing this. So obviously, to find the length of this other side, I could use the Pythagorean theorem. That would be the simplest way to go about it. But we might do that using some trig instead, just for practice. Let's start off with the angles, though. So let's find this angle. Call it theta. Okay, so I just chose which angle I wanted to find first. All right, relative to this angle theta, I know the adjacent side and the hypotenuse. Well, that's going to involve cosine. Okay, so cosine of theta, I don't know what theta is this time, so I'm just going to leave it as theta. Cosine of theta is equal to the adjacent, which would be 6 feet, over the hypotenuse, which would be 10 feet. Okay, notice that my feet cancel and I'm just left with a pure number. Right, so cosine of theta equals 6 over 10, and just for fun, I'll reduce that to make it 3 over 5. All right, so how do we find theta? All right, so later on we're going to talk more about this cosine being a function, cosine of theta being a function, and we'll take the inverse of that function. But for right now, just understand this next thing that I'm going to do is just to undo this cosine of theta. Okay, so to find this theta, I'm going to do the inverse cosine of both sides of the equation. So when I do that, I'll get theta equals the inverse of the cosine, and we're going to represent that with this little symbol here. We're going to put a -1 up there. So the inverse cosine of 3/5. So this is just like if you had x squared equals 9 and you took the square root of both sides. Okay, so that's the same thing I'm doing here. I'm just undoing that. I'm using an inverse function to solve for theta. All right, so theta equals the inverse cosine of 3/5. This would be the exact answer. But maybe I want an approximate value to that, so I'm going to talk to my calculator. And I'm going to ask it for the inverse cosine of 3 divided by 5. And it's going to tell me approximately 53.13 degrees. All right, good. So this angle is approximately 53.13 degrees. All right, let's find this other angle up here. Okay, so obviously one way I could do it is just find the number that has to go here so that these two add up to 90. But let's use trig just for practice. So say I want to find this angle. Let's call it alpha. All right, so relative to alpha, I know the opposite side and the hypotenuse. So that's sine. So let's do that. So the sine of alpha equals the opposite side, which would be 6 feet, over the hypotenuse, which would be 10 feet. So again, my feet cancel and I'm left with a pure number. So the sine of alpha is equal to 3/5. Okay, to find alpha, I'm going to undo the sine. So I'm going to do the sine inverse of both sides and get alpha equal to sine inverse of 3/5. And so this is the exact answer. But say I want an approximate value for that. So alpha is approximately equal to, talk to my calculator, I'm going to ask it for the sine inverse of 3 divided by 5, and it's going to tell me 36.87 degrees. Okay, so this angle is 36.87 degrees. All right, do these make sense? So these two should add up to 90. Do those add up to 90? So 36.87 plus 53.13, and that adds up to 90. So we can be confident we got that right. All right, one more thing to do. We got to find this last side over here. So the easiest thing to do would be to use the Pythagorean theorem. So let's do that. So 6 squared plus, let's call this x, plus x squared equals 10 squared. So we have 36 plus x squared equals 100. Subtract 36 from both sides. X squared is 64. Take the square root of both sides. X equals plus or minus the square root of 64. Square root of 64 is 8. So x equals plus or minus 8. The length of the side of a triangle is not going to be negative, so we only want the plus value. So we get 8. So this should be 8 feet.